Alright guys, you are welcome to a next tutorial. Today we shall be looking at the dynamic programming uh, and we shall be considering an example which is making change. How you can make a change using dynamic programming. So uh, you know that dynamic programming makes use of a concept that is called memoization. And what memoization simply means is that you are reusing already computed values. That is, if you have a particular computation in your previous executions, you don't need to recompute that computation again. You can just store that computation in a variable, and when you need to recompute the same computation again, you just need to fetch the value from memory, so you don't need to do the computation again. So memoization is a technique for you to be able to reduce the time complexity that it takes for an algorithm to execute. And so this is the intuition behind dynamic programming. So let's look at that with an example in making change. What this problem is about is, take for instance that you go to a supermarket and you give uh, the attendant, you're paying for the items you have bought, and you give the attendant a certain amount of money, call it A, call it capital A, and you are supposed to collect change after they have deducted the value of what you have bought. So the change that you're supposed to collect is represented as A. So now, to give you the change, the attendant needs to look at the denominations that are available and give you your change in the available denominations. This problem is trying to look at how can the attendant give you your change, which is capital A, in such a way that she uses the minimum number of coins, available. That is, she uses the minimum number of denominations available. Of course, if the denomination of 1 unit, if that is available, no matter your change, she can decide to give you all in 1 unit. Let's say, for instance, it's in dollar, so can just decide to give you all in 1 cent. So you just have that or true. But that will not satisfy the constraint of giving you the minimum number of coins. For instance, if your change is 30, let's say it's 30 cent, if your change is 30 cent and the available denomination is 1 cent, 10 cent, and 25 cent, for the attendant to be able to give you minimum, a greedy approach would be that she would first of all give you 25, but then after giving you 25 cents, she needs to give you 5 more additional cents. And now, since in the collection of denominations that are available there is no 5 cents, then she will be forced to give you 5 of this. And if it takes 5 of this D1 and takes 1 of this D3, this is going to be 6. And so the number of denominations in total that will be given is 6. You will see that this is not optimal. It's not optimal in the sense that it is better she gives the denomination 2, which is 10, and all she will need to give is just give you 3 of this. We make up the 30-cent change. So what is optimal is for her to give you 3 of this. So, and that is what this is saying, that the greedy approach is not always optimal, as it is shown in this case. So now we're going to look at how we can use dynamic programming to be able to solve a problem like this. So we take another example. In this example, the denominations that we have are 1, 4, and 5. We have 1, 4, and 5. If you want to use it in currencies, you can say 1 cent, 4 cent, 5 cent. So those are the units of our denominations. Now the amount, that is the change that the customer wants to collect, is 8. That is the change that the customer wants to collect. So how can we give this change, this 8, let's just use cent, how can we give this 8 cent in such a way that we use minimum number of denominations? Don't forget that what we mean by number of denominations is the counting of the denominations. That is, for instance, here a greedy approach will be that we give 5 cents and we give 3 of 1 cent, and that is going to make 3 plus 1, and that is going to be equals to 4. That means we'll be giving 4 units. But the optimal approach is for us to give 4 plus 4. That is, we give 4, which is going to give us 2 units. That's just going to be 2 for us to get 8. So this is how dynamic program approaches the problem. So let's go through how this table is populated. So in dynamic programming, we normally construct a table, and the rows is going to be the denominations. So on the row is going to be the available denomination. So this is for the first denomination, the second denomination, the third denomination. Now we have a variable here called I that starts from 0, and it corresponds to the denominations. So for instance, if I say di, if I have di, so if my I is 1, so if I say d1, then it means I'm referring to this denomination. If I say d2, it means I'm referring to 4, this denomination. And if I say D3, it means I'm referring to this denomination 5. So I normally start from 0. Now on our columns, we're going to have the amount. Now you will see here that we have represented the amount with small letter a. The reason is we're going to do a calibration of the total amount which we are representing as the change that the customer wants to collect. We're going to enumerate for each values of the amount incrementally until we get to the total amount. We're going to enumerate the possible values for this table. So when the amount is 0, when the amount is 1, 2, 3, 4, 5, 6, 7, where we are going to enumerate all these solutions for all these possibilities. And that is the concept that we talked about, that dynamic programming uses memoization, meaning that the solution that have been pre-computed for smaller instances of the problem will be reused for larger instance of that problem. So here, even though our amount is 8, this is what we need to compute. For us to be able to use memoization, we have to compute all the smaller instances of the amount. Okay, so now if the amount is 0, if the amount is 0, then definitely there is no need for us to give any change, because the customer does not have we are not owing the customer any change. So all the entries in this table, starting from here, all these entries here represent the change that we're given. It represents the change that we're giving the customer. It represents the number of units of the change that we are giving the customer. So if the amount is 0, then we don't have any change. We are not owing the customer any change. So all this is going to be 0. So we are not giving the customer any unit of our denomination. It's going to be 0. Now, if our denomination is 0, then that is what we call an undefined solution, because we don't expect us to run into such problem. That's why we enter undefined in this row, because if the customer asks if we have an amount, we are owing the customer a change, and we don't have any denomination left, this means 0, no denomination. This is an undefined situation. This is an undefined. We cannot put 0 because we are owing the customer. 0 means we are not giving anything. We are owing the customer, but then we cannot give anything because our denomination is finished. Maybe there are no more coins in the safe, or no more denomination in the safe. So this is an undefined situation. All right, so having done this, and this, then we start from here and start looking at the corresponding amount and the denomination. Now what this is saying is that if the amount is 1, if the amount that we're owing is 1, and we have a denomination of 1, for us to be able to pay the customer, there is a match. We just take that denomination. We just take 1 unit. This means 1 unit of this denomination. If the amount is 2, for us to pay the customer, we just take 2 of our DI, which is 1. We just take 2 copies of it. Remember, all these are number of copies of the denomination. If the amount is 3, we just take 3 copies. If the amount is 4, we just take 4 copies to be able to pay the customer, and so on, and until we get to 8. If the amount is 8, we just give the customer 8 copies of DI. Each time we are considering an entry into this table, each time we are populating this table, we always consider from that particular row where we are in, we consider the denomination from that row and the denomination before that row, the previous, all that are before, to be able to satisfy the customer, to be able to pay the change. So we move on to here. Now, if the amount is 1, this is 1, the amount is 1, and we can give the customer either 2 units or 1 unit or 0 units. But because we are owing the customer 1 unit, the best way for us to be able to satisfy the customer is to give 1 unit. So to be able to satisfy the customer, we give 1 unit. So this is what we give. So we give 1 unit to the customer. So we give 1 unit. Now, if the amount, you will discover here, oh, this is what I'm trying to say here. These are our denominations. This is 145. 145. So if the amount is 1, we can either give the customer 1 or 4. This is what I wanted to say, not 0, 1, 2. So if the amount is 1, we can only give the customer either 1 or 4. But we can't give the customer 4 because that means we are giving over change. We'll be losing money if we give the customer 4 units, because what we are owing the customer is less than 4 units. So we look for something that is less than 4 units, which is this. So we definitely give the customer 1 unit. So we give 1. Okay. If you are owing the customer 2, if the amount is 2, we give the customer, we can either give 4 or 1, but what we are owing is less than 4, so we give 2 copies of this. So this is 2 copies of this, so we give 2 to satisfy 2 copies. Don't forget, these entries are number of copies of the denominations. Now, if you are owing the customer 3 units, we give the customer 3 copies of 1 because we can't give the customer this 4 is less. What we are owing is less than 4, so we don't want to lose. But if we are owing the customer 4, then to be able to give the minimum, we have 2 options. Is either we give the customer 4 units, which is 1 copy, or we give the customer 4 copies of 1 unit. Since we want the minimum, so for us to give the minimum, we give 1 of 4 units. So we give just 1 of the 4 units. Now if you're owing the customer 5, what do we do? For us to be able to have the minimum, we can take either 5 of these. Definitely we cannot take 2 of this, but we can take this and what is before it. So the best is for us to take 1 unit of 4 and 1 unit of 1, so we give 2 copies. If the amount is 6, as you can guess right, we take 1 unit of 4 and we take 2 units of 1, so we get 3. And if the amount is 7, we take what? 1 unit of 4 and we take 3 units of 1, and that will give us 4. If the amount is 8, then we take 2 units of 4, so 2 copies of 4 of denomination 4 will give us 2. You know, we can also take 8 copies of denomination 1, but because we want the minimum, so we take 2 copies of this. And that's that for this. Then we come here. From here, if the amount is 1, we can either give 5, 4 and 1, everything from this row and before, 5, 4, 1. But we can't give 5 because it's more than what we are owing. We can't give 4, it's more. So the best is for us to just give 1 copy of 1 unit. If the amount is 2, we just give 2 copies of D1 of denomination 1 of this. Just give 2 copies of 1 unit. If the amount is 3, we just give 3 copies of 1 unit. Don't forget these are copies. If the amount is 4, the best is for us to just give 1 copy of 4 units. So that's 1 copy. If the amount is 5, now we have several options. We can give 5 copies of 1, or we can give 1 copy of 4 and 1 copy of 1, and this will give us 2. But we can also just give 1 copy of 5, and that is the minimum. So we take 1 copy of 5, and that is 1. For 4 we just take 1 copy of 4. For 5 we just take 1 copy of 5. So this gives us 1 copy of 5. Now for 6, we can either take 1 copy of 4 and 2 copies of 1, and that is going to be 3 copies. Or we can take 1 copy of 5 and 1 copy of 1, and that will give us 2 copies, and that's the minimum that we can have. If the amount is 7, to get the minimum, we take 1 copy of 5 and 2 copies of 1, and that will give us 3 copies. You know, we can also take 1 copy of 4 and 3 copies of 1, but that is going to give us 4 copies. So the best is to go for 3 copies. Now if the amount is 8, what do we take? As you can guess, instead of taking 1 copy of 5 and 3 copies of this, which will give us 4, so we will not take this 5, we'll just go and take 2 copies of 4, which will give us 2. So this is how this table is populated for dynamic programming. Now, if you observe very well, you will discover that some pattern in this table. For instance, you will see that here, whenever we have a value that does not take exactly what is needed, for instance, if you look at here, this one is just 1 copy of 4. You will see that everything that is before it is the same as what is here. And you look at here too, from here, everything that is before it is the same as what is here. That is memoization. So that is memoization. We're just recopying what is above here, what is above. We're not recomputing it. It's just copying what is above here to be able to make sure it is faster. Alright, so how do we know which coins? Don't forget we said all these entries, they are number of copies of coins. For example, these 2 could be 2 of 4, or 2 of 1, or 2 of 5, or 1 of 5 and 1 of 4, or 1 of 5 and 1 of 1, or 1 of 4 and 1 of 5. We don't know. So how do we know which particular coins give us this number of copies? So how do you do that? You start from this final entry. This is the final entry. You check this final entry on its column. This is its column. You check the value of the final entry and the value on the previous row in its column. So if this value is the same, then it means that this particular denomination has not contributed anything in our result. It means that this particular denomination has no effect in our result, so we discard it. That means this denomination was not taken. Now we do the same. From here we compare with the previous value in the row. In the previous row, compare with the value in the previous row on the same column. Now this is 8 and this is 2. You will see that there is a difference here between 8 and 2. They are not the same. And what that means is that this particular denomination contributes to our result. So we have found one denomination. So that means 4 contributes to our result. Denomination 4. That is the first denomination that contributes to our result. So what do? We have already gotten 4 units. So we remove the 4 unit from here, from our total amount. So we have 8 minus 4, and that will give us 4. So the next is for us to look at where is this remainder of 4, which denomination contributed to this remaining change of 4. So to do that, from this particular row where we have gotten the first answer, we jump to 4. because this is 4. So we move to 4. We move to column 4. Whatever column it gives us, we move to that column. So we're in this row, so we move like this to column 4. So when we get to this place, we check again this and its previous row. We check the value of this and its previous row in the same column, in that column 4. If the value is different, it means that this particular denomination contributed to that 4. In this case, it is different. Then it means that this denomination contributed again into the 4. So we have gotten the second one. So the second denomination is 4 again. So we remove this 4 from here, and that will give us 0. Now since we have already gotten 0, we don't have any denomination again. And even if you want to do it, all you just need to follow again is from here, where we have gotten that particular result. So we got the particular result. From here, you jump to 0. And of course, 0 is the same as 0, which means this one does not contribute. Again, 0 is the same as 0, which means this does not contribute, and 0 is the same as 0. So definitely there's nothing to add again. 0. So that is that. That's how we got the 2 units, and those 2 units came from denomination 4. Now this is the outline of the algorithm that we followed to be able to populate the table. If a equals to 0, then 0. Else if I is 0, then infinity. Else if a is less than di, then you take what is before. This is I minus 1a. You take what is before. What this means is that the C is the entry in the table. This is our I. So I minus 1, that means you take what is in the previous row in the same column. That will be the entry. Else, if the amount is equals to the denomination, or the amount is greater than denomination, you take the minimum of the previous row, or the minimum of the previous row, or you take that particular row plus 1. Plus 1 means that you have already taken that count. So this helps you to have a count, to increment that you have already taken an instance from there. So that's the algorithm. You might want to follow that. If you use this algorithm, you will discover that you arrive at this entry. Another algorithm that you might want to use is also provided here. So this is the denomination, and here n represents the amount. So n in this case will be our 8, and denomination here will be 1, 4, 5. And you can also follow this algorithm, and you discover that you get the same result. At the end of the day, this will return the denominations and the number of denomination. You'll be able to count how many and the particular denominations that gives the change. Okay, so thank you very much for listening. if you have any comments, please do comment below, and would like you to look at this particular example where we have 25 1 10 25 and the amount is 30. You might want to give it a try and comment your answer below to be able to see what you have in your entries, in your table entries. And if you like this, please do give us a like, and if you don't like it, please give us a dislike. All this will help us to be able to improve in our subsequent series.